A piston and a cylinder machine contains a fluid system which passes through a complete cycle of four processes. During a cycle, the sum of all heat transfer is 170 kilojoule. The system completes 100 cycles per minute. Calculate the following table showing the method for each item and compute the net rate of work done in kilowatt. Okay. During the cycle, the sum of heat transfer is minus 170 kilojoule. The sum of heat transfer means summation of Q is minus 170 kilojoule, and the system completes 100 cycles per minute. Complete the following table showing the method for each item. That is, we have to find the values of all these processes showing their process and compute the net rate of work done or work output in kilowatt. We have to find summation of W for a cycle. We have, that is, we have Q is equal to, that is, summation of Q is equal to minus 170 kilojoule. We have summation of Q for a cyclic process which is equal to minus 170 kilojoule, and we have to find summation of W for a cyclic process. We have to find. Okay. From the process A to B, that is, for the process A to B, we have the value of heat transfer and work done by the system. We have to find the change in internal energy. Okay. This can be found by using the first law of thermodynamics for a closed system, which states that Q is equal to del U plus W or del E plus W. In this case, it is del E. Therefore, we have to find the value of del E, which is equal to Q minus W, and del E is equal to, we have to substitute the value of Q and W, which is 0 minus 2170, and the change in internal energy is given by del E is equal to minus 2170 kilojoule per minute. Okay, and we have found out the value for this. Okay, then we have to find the value of change in internal energy for the process B to C. That is, for a process B to C, we have to find the value of del E. And for process B to C, we have to find the value of del E, which is nothing but Q minus W. And we have the value of Q as 21,000 minus 0, and the change in internal energy will be equal to 21,000 kilojoule per minute. Okay. And in the next process from C to D, we have to find the value of work done. Okay, we have to find the value of work done, which is nothing but W is equal to Q minus change in internal energy, which is nothing but Q is equal to minus 2100 plus the change in internal energy is 36,600, and we will be getting a value of 34,500 kilojoule per minute. Okay, we have found out the values for all the values for this three process, and in the fourth process we don't have value of Q, that is the heat transfer, work done, and the change in internal energy. All the three values are unknown, but we have the value of summation of del Q. That is summation of Q. We have for a cyclic process, we have Q is equal to 170 kilojoule. By substituting this value, we can find the value of Q of dA. Okay, we have summation of Q cycle, which is equal to minus 170 kilojoule. Okay. The system completes 100 cycles per minute. Okay. The system completes 100 cycles per minute, and this can be elaborated as Q of AB plus Q of BC plus Q of CD plus Q of DA, which is equal to minus 170 into 100. That is, since a system completes 100 cycles per minute, we are multiplying with 100, and this will be equal to kilojoules per minute. Okay. We are having the value of QAB as 0 plus QBC is equal to 21,000, and Q of CD is equal to minus 2100 plus Q of DB, which is equal to 17,000. Okay. From this, Q of DB will be equal to minus 35,900 kilojoule per minute. Okay. Thus we have find out the value of Q of dB. And you have find out the value of heat transfer, but the work done and the change in internal energy remains unknown. Okay. But we can find the value of del E, that is change in internal energy, by a property or by an equation which is cyclic integral of any property will be equal to 0. That is, since change in internal energy is a property of a system, and according to mathematics, cyclic integral of any property will be equal to 0. Therefore, we are using this equation to find the value of change in internal energy of del E dA. Okay. And if you sum it up all the change in internal energy, you will be getting del E of AB plus del E of BC plus del E of CD plus del E of dA. This will be equal to 0 since cyclic integral of any property is equal to 0. That is, cyclic property, that is cyclic integral of any property, cyclic integral of any property, integral of any property is 0. By using this, you have found this equation, and from this you have the value of del E of AB, which is minus 2,170 plus del E of BC is 21,000 minus del E of CD is equal to 36,600 plus del E of dA, which is the unknown value, which is equal to 0. And if you calculate, you will be getting del E of dA, which is equal to 17,700 kilojoule per minute. And you have find the value of del E of dA. From this, you can find the work done for the process dA. Okay. From this, you can find the value of work done, that is W of dA will be equal to Q of dA minus del E of dA, which is equal to minus 35,900 minus 17,700. Okay. From this, you can find the value of W dA, which is equal to minus 53,670 kilojoule per minute. Okay, we have found out the value of WDA. Okay, and here we have just done a mistake, which is dA, Q of dA. So this will be Q of dA and this is Q of dA. Okay, we have found all the values and we can substitute these values in this table, and del E of AB will be equal to minus 2170. That is, this value is minus 2170 and del E of BC is 21,000. This equation will be having the value of 21,000, and work done in the process CD will be equal to 34,500. This is 34,500, and we have the value of Q of dA is equal to minus 35,900 and W is equal to minus 53,670. That is from here, and del E is equal to 17,700. Okay, 17,700, and we have found all the values in the table, and now we have to find the net rate of work output. That is, we have to find the net rate of work output. That is the question. We have complete the following table showing the method for each items, and we have done it, and compute the net rate of work output in kilowatt. We have to find the net rate of work output in kilowatt. Okay, and we have to find summation of W cycle, which is equal to, we have to add all the, sum it up all the values of work done, which is 2170 plus 0 plus 34,500 minus 53,670, which will be equal to minus 17,000 kilojoule per minute. Since this is in kilojoule per minute, we have to change it into as kilojoules per second, since 1 kilojoule per second is equal to watt. Okay, therefore we have to divide it by 60. That is minus 17,000 divided by 60, which will be equal to minus 283.3 kilojoule per second. Okay, therefore the work done or the net rate of work done is given by the value of W is equal to minus 283.3 kilowatt, which is equal to minus 283.3 kilowatt.